Okay, then I'm going to do that row in the next column. Okay, so then I'm going to go a 4 times 2 plus a 0 times 0 plus a negative 2 times 4. So row, column, okay? Then I'm going to go to the next row. So then I'm going to have a 2 times a negative 2 plus a 1 times 3 plus a 4 times 1. I always find the second row harder to do, something about your eyes don't track it as well. And then this row and that column. So 2 times 2 plus 1 times 0 plus 4 times 4. Okay? Now I have to do the math out. So the result, we'll put down here. Okay, so this is going to be a negative 8 plus a 0 plus a negative 2. So I have a negative 10 right there. Then I have an 8, a 0, and a negative 8. So I have a 0 right there. Then I have a negative 4 plus a 3 plus a 4. So that's going to give me a 3. I have a 4 plus a 0 plus a 16, which is going to give me a 20. Okay? Now, I know that that's going to be the right dimensions because this one is a 2 by 3, this one's a 3 by 2. I look to make sure that I can do it by comparing those middle terms. If they match, I can do it. The result is going to be your outside terms. The result is going to be a 2 by 2, which is what we have. Okay? Yes, no, maybe? Okay.
Yeah,
it's almost like you have to be able to naturally do it and not think about it. Okay? It's got to just be, you know, natural response, if you will. Okay, I'm looking here. That's about it for that section. Okay, so that was just an back intro to the thing, to matrices. It was scalar multiplication, addition, subtraction, and multiplication. Now, most people will say it's worth it to put that into your calculator. Okay, the addition, subtraction, scalar multiplication, maybe not. But if they are wanting you to multiply, it might be worth it because it's real easy to make careless mistakes on that. The time that you always use a calculator is like if they give you 4 or 5 matrices up there, and then they give you a whole bunch of like mathematic equations to do. So they give you that, and then they give you that, and then they give you something like that, and then they keep going. Obviously what you would want to do is you would get an A, B, and C matrix, and then just pull them out of the calculator to do the math on them. So in that sense, it would be worth it to put it in there. All right, so that's section 2.3. Well, why do you ever have to use matrices? We used them in terms of transformations. Do you remember what transformations were on a coordinate plane? Transformation is like moving a graph. Like you slide it, you flip it, you rotate it, okay? Again, I would not necessarily use matrix for all of it. You can, but I just don't know if it's worth it. We talked about different kinds of transformations. Again, this is all review. You talked about translations. Talked about, let's see, reflections. Dilations. And rotations. Okay? You've done that last couple years. Let's say I have a triangle. I say, you know what, I want to translate, or another word we use for translate, some books use the word slide. And I go, I want to slide this thing 4 right and 2 up. Okay, do you remember what we did to do that? Without the matrices.
4 to the x and 2 to the y.
That's exactly, okay? I add 4 to the x values. Every x value that I have, I add 4 to it. Every y value I have, I add positive 2 to it. If it had said left, I would add a negative 4. If it said down, I would add a negative 2. So what I did when we did that is I set up like a table, and I said 2 to negative 3, 0, this is A, B, and C, and I have 1, negative 4, and what I wanted to do was I did x plus 4, and I did y plus 2, and I resulted with an A prime, a B prime, and a C prime. Do you remember that? The prime stuff? So this is going to give me 6, positive 1, positive 5, 4, 2, and negative 2. Okay, all I did was I changed my points. Okay, so when I go to do it over here, I just regraph it. So I get the point on 3, 4, 5, 6, 1, 2, 3, 4. So this is A prime, and B prime is 1, 2, which is going to be right there. So that's going to be B prime, and C prime is going to be 5, negative 2, which is going to be right there. So it just slides. Remember that? Well, you can take a matrix and you can do it. But again, don't think it's worth it. Okay, the way that you do a matrix is you set it up with the x and the y. Okay, so my matrix looks like this. 2, 2, negative 3, 0, and 1, negative 4. With my x's and my y's. And they match up. Okay? To slide it, remember these are my x's, and I'm adding 4 to my x's. So I would add the matrix 4, 4, 4, and 2, 2, 2. If I add this plus this, I get the resulting matrix, which would be 6, 4, 1, 2, 5, negative 2. I don't think it's worth it. Okay, because literally by hand you are adding those. You can put it in a matrix form and have your calculator do the work for you, but I just don't see why it would be worth that. Okay, do you see what I'm saying? Okay.
What's the prime stuff again?
Prime just means like the second point.
Oh.
It just distinguishes. It distinguishes that you've done something to the first point. Like in this sense, I translated it.
Right.
You can have double prime, you can have triple prime, you can have, so you can have as many primes on it as what you are changing the points. Okay, it just means that there's something been done to the point. It's been transformed. Okay, so that's how you would use matrices with translations. Again, don't know that it's worth it. Okay, let's, for the sake of leaving this up here, this is another one that we can do real quick and let you see it. Let's skip down to dilations. Do you remember what dilations is? How about when you get your eyes dilated at the eye doctor? What happens? Yeah, well, the pupils open up and it gets bigger. Dilation literally means expanding or contracting, okay? Let's say we wanted to dilate this by a factor of 2. That would mean I would take every one of these points and I would multiply 2 times that point. So this is 4, 4. This would be negative 6, 0. And this would be 2, negative 8. Those are going to be my new points. So I have, I might not be able to do them on here, but, Okay, that's going to be A prime, negative 6, 0, that's going to be B prime, and 2, negative 8. Is going to give me C prime. Okay? That was by a factor of 2. If I want to make this smaller, let's say I want to make it by a factor of 1/2. Well, then I multiply everything by 1/2. Now, can you do it with a matrix? Absolutely. I would just put a sucker 2 on the front of it. So I'm going to do scalar multiplication. Again, I go, why? When I can take each individual point and just multiply it by 2, I don't see that my matrix is really benefiting me that much.
More chance to get confused.
Exactly, because then I've got to translate it from there over to there, and why in the world would you put all that in a calculator? Okay, now if you got big old numbers and they're multiplying it by a scale factor of maybe 1/7, and you don't want to do all that, and you want the calculator to do it, you can always use the calculator. But for most of our points, I just don't know that it's worth it. It's not good time management. I'm not saying you can't do it that way. So that's this one, dilation. I don't even think I think we use dilation as the same term for that. But I'm gonna put scalar here, because literally it's scalar multiplication when you're doing the matrices, okay? But again, both of them, I don't know that it's worth it. All right, now, it might be worth it when it comes to reflection. I want you, because reflection, remember, if it reflects over the x-axis, well, I don't even know if it would, okay? Let me erase this. What happens when you reflect something over the x-axis? Do you remember? The y changes. Okay, if I were to take this point and put it down here, it would become 2, negative 2. Okay, so let's say I want to reflect this over the x-axis. Then what happens is this becomes 2, negative 2. This becomes negative 3, 0, doesn't change. And this becomes 1, positive 4. All I did was change the y positive and negative, okay, to the opposite of what I had. What happens when I reflect it over the y-axis? What changes? The x. Okay, then I just take the opposite of the x. Now, I can also reflect it over, and I'm trying to think, okay, y equals x, okay, which is this line right here. And what literally happens is you switch the x and the y's place. Okay, you remember that. Then if you had y is equal to negative x, you switch their place, but you also take the opposite of both. Okay, we learned all that stuff between Algebra 2 and Geometry. But go ahead and open your book to page 90 and let me show you something on this. And this might be worth it, but I kind of doubt it. Okay, you there? Okay, on page 90 towards the top it says reflection matrices. So if you are reflecting it over the x-axis, you have to multiply your matrix by 1, 0, 0, negative 1. Okay? If you're doing it over the y, negative 1, 0, 0, 1. So if you take your points and you set it up in a matrix form, you can multiply it by that matrix to reflect it over. Again, if I'm just reflecting it over the x-axis and all I'm doing is changing the y values to the opposite of it, I don't know if it's worth it. Because I got to memorize those things for one thing. And so the memorization of it, it'd be way easier just to remember that when I reflected over the x, I just changed the y. When I reflected over the y, I changed the x. When I reflected over the y equals x, I just switched the x and the y. Okay? I really think that's the easiest way to go. Reflection was the same thing as flip in some books. Now, so my speculation is you're not going to use a matrix for any of those three. You can, it's possible to, but you don't have to. I don't think it's the easiest way. However, rotation is the exception. If you remember right, with rotation, literally, you would need, what did I do with all of them? You would need a protractor. But I don't know where my protractors are. Oh, wait, here they are. No, they're not. You would need one of these to do this. And even when you do that, it is not exact. Because if I said I wanted to rotate this thing 30 degrees, okay, so all of a sudden, this point right here has to rotate up to about here. Then I'd also have to use, they need like little things on this so that they come off. I would also have to measure the distance there so that it's the same distance when I move it up 30 degrees. That's a pain in the neck. It's not easy to do a rotation. Versus, you look at your book on page 91, and they give you rotation matrices. So for 90 degrees, you have 0, -1, 1, 0. So if I'm going to rotate it 90 degrees counterclockwise, all I have to do is multiply that matrix times this matrix. Now I'm going to have to go this times that, because if I try and do it the other order, it's not going to work. Okay, because the rotation matrix is a 2 by 2. This is a 2 by 3, which means I've got to put the rotation matrix in the front. Okay? What I suggest is somewhere down on your matrices, whether it's, I don't know, G, H, and I, somewhere down there, put those 3 rotation matrices in there so that you're only pulling them up when you're doing rotation. But don't put them under like A, B, C, D, or E, because those are the matrices you're going to add in there, okay? So you want to put it in your calculator in a spot that you're not going to need to use it, so that you can just pull it back out. Yeah, you can memorize them, but I don't think I would necessarily go to that effort. Okay, is that making sense to you, what I'm saying? Let me show you, I'm going to have you do one for me. See what you get as a result of it. Now, I would highly recommend calculator.
For rotation.
This is a rotation. Okay, here are your points.
Remember we did these last year right after I hurt my thumb?
Yep.
It was so hard.
Okay. I'm going to temporarily turn this off here.